All right, everybody, thanks for tuning in. I just wanted to go over some of the answers from this handout. And remember that this covers the entire chapter and not just the recent stuff. So it's a nice summary of some of the major concepts. So let's jump right into it. Number 6 is of the 100, one of the 839 is randomly selected. Find the probability of getting a challenge that was rejected. So the total is 839, but I summed up the number that of rejections. There's nothing about the gender on there, and so that would be the setup for number 6. I'm going to move quickly, but ideally, if you substitute these fractions into your calculator, you could get a decimal. It's a simplified answer. Second one, it says find the probability of getting a challenge that was made by a male player or was rejected. So the setup here is we want the probability that they're male plus the probability that it was rejected. And then we have this potential overlap. So male and rejected. We don't want to double count. And so I got my male players up here. There's a 489 out of 839 probability that it's male. But the probability that they're rejected is 512 out of 839. And if you forget to subtract it off, right now your answer would be 1,000 over 800, and you're already past 100%. So there's something wrong here, and you want to subtract off the overlap. In this case, the overlap is the males that were rejected. I just circled it. It looks like there's a 288 there. And so when we subtract that off, we'd be subtracting off the double count. So again, I'm more concerned with the setup right now, but if you punch all those in or break it out, you get the final answer. All right, number 8. Find the probability getting a challenge that was accepted and made by a female player. So female players are on this one, accepted's on this one. The overlap here, or the combined, is just straight up 126 over 839. That's it. Don't overthink it. Number 9, find the probability of randomly selecting 2 different challenges and finding that they were both accepted challenges made by female players. So the difference between this one and the last few is that you're now looking at 2 events. The last few you were just looking at 1 event. And so the first event is that you're finding an accepted challenge made by a female. And so accepted made by a female, it looks like is that 126 over 839. And that was the answer to number 8. But now when you have multiple events, the idea is you're multiplying by the next probability. And so now you need to find another accepted by a female. And the idea is there's 1 less female and 1 less in your total. And so when you take the product of those 2 things, again, I can't do this without a calculator, but that would give you the final answer for that one. Again, 2 events versus 1. All right, number 10, find the probability of randomly selecting 1, so again, back to 1 event, and getting a challenge that was accepted given that it was made by a female player. So there's kind of an idea in here, if you need to brush up on your skills. This is referring to something called conditional probability. And a lot of times for you guys, it'll come up in a table like this. But the given that means that we only care about female players. It's like our subgroup. So this is the first one, I think, on this where the denominator is not going to be 839. The denominator is going to be 350. We're saying just look at the female players And now what's the probability that it was accepted? There's a 126 out of 350. Again, this was this bottom was the total females now. And the hint there was from the fact that it said, given that, we're just looking at the females, given that it was made by a female player. All right, let's look at the next one. The burglaries question. It says 12% of burglaries are cleared. So I'm just going to label that with the probability of an arrest is 0.124 or 12.4%. A new detective is assigned to 5 different burglaries. So that's a hint there that there's going to be 5 events. And they are independent of each other. Or I guess we can assume that they're independent, meaning it's 5 different cases. All right, letter A. What is the probability that at least one of them is cleared with an arrest? All right, so this is a tricky question. You could have 1 arrest, you could have 2 arrests, you could have 3 arrests. At least means 1 or higher. And so I think this is one of the hardest ones maybe on this handout. But I want to remind you of the fact that the probability of no arrests, and I can't spell. The probability of no arrests plus the probability of 1 arrest plus 2 arrests plus 3. So all the combinations would add to 100%. Or we can break it down to at least 1 arrest equals 1. This was a theorem that we talked about. That covers every combination. Either, no people get arrested, or at least 1 gets arrested, and kind of break it down into those groups. And so it's kind of hard to find this one, which is what the question's asking for, just because there's a lot of different combinations. But it's actually easier to find no arrests. And so let me just remind you of a few things. The probability of not being arrested is the complement of 12%. If you have a 12% chance of getting arrested, then the complement of that would be 1 minus that, which is going to be 0.876 or 87.6%. And if you have 5 events, I tried to do this with license plate questions, passcodes, horse racing, all that stuff. But like this is your first case as the detective, and the probability of not getting arrested or not making an arrest is 0.876. And the second case, again, same thing, you're not making an arrest. And if you're trying to find the probability of no arrests, well, you're going to have this 0.876 all 5 times. That represents no arrests 5 times. And you could write it as 0.876 times 876 times 876, or you could just take 0.876 and raise it to the 5th power. 0.515. 516 if you round. Again, this is one of the trickiest on this whole handout. So this is the percentage that there's no arrests. So if I go back to this original statement, the probability of no arrests plus the probability of at least 1 having to be 1, I now got that this probability is 0.516. And if I treat this like a math problem and I subtract 0.516 from both sides, 1 minus 0.516, I get 0.484. And that is the answer to number 16A. Tricky, tricky stuff. All right, let's look at 16B. It says, what's the probability that the detective clears 5 burglaries with arrests? We actually set ourselves up for this. So again, we have 5 events. But now, you know, the probability of arresting the first guy is 0.124. Another event, times it. Next guy is 0.124, times it. 0.124, times it. So my setup, hopefully kind of see it coming. This is the probability of all 5 arrests, which would be, you know, 0.124 raised to the 5th. And I got something in scientific notation. I'll just remind you guys how to interpret that. I got a 2.93, and then it says, you know, E negative 5. And if you forgot what this means, it means 2.93 times 10 to the negative 5th. And still, might not remember what that is because it doesn't come up too often. Negative 5 means I can move this over 1, 2, 3, 4, 5. And so the actual answer would be 0.0000293-ish. And that is a very, very, very small percent of making all 5 arrests. So this last question is kind of an interpretation. What should we conclude if the detective clears all 5 burglaries with arrests? Oof. That is a very, very small, that is unlikely to happen. Maybe there's something going on behind the scenes that we want to check into. And so, again, very, very, very low likelihood. Okay. Let's pause there. I'm going to come back with another video and do the next couple questions. So thanks for tuning in. See you guys soon.